C of this question. I did the part A and B in my previous videos. Here I'm going to focus on the part C. Now let's see what this part C is asking. In the part C, the question is asking for each of the each of the three cases in part B. Find the percentage change in AF that results when A decreases by 20% and comment the results. Okay. In the part B also we did exactly the same thing. We found out the percentage change. Okay. Actually we found out the R2, but here we are going to find out the percentage change. Now let's see how to find out the percentage change. First of all, in order to find the percentage change, we have to know the closed loop gain. To calculate the closed loop gain, we have to find out what is going to be after 20% decrease. So in order to calculate 20% decrease of this gain, what we need to do is, let's say we put a new, and I'm looking at the case 1. Okay, let me put 1 right here. In the first one, we have 1000 voltage per voltage. That's the initial gain, and if it decreases by 20%, it means the new one is going to be a minus. Since it's decreased, we put a minus, and then a times, since it's 20%, I put 20 over 100. Okay, now plug the value. This is 1000, and then minus 1000 times 20 divided by 100. So we are going to have 200. So this is 1000 minus 200. That's going to be 800 voltage per voltage. So this is going to be the new gain. Now for this one, we have to find out the percentage change. To calculate the percentage change, first we have to find out the closed loop gain for the new gain. The closed loop gain is basically A over 1 plus A beta. Okay, now here the beta value is based on part B. If you look at my part B video, I calculate the beta for each situation, because in order to find out the R2, we have to calculate the beta first, because beta is R1 over R1 plus R2. We did this one in the part B, but here we don't need it, but we need that beta value. So I'm going to bring that one here, and if you want to know how did I derive it, you can watch my previous video where I did the part B. In the part B, we found out the beta values. So here A value is 800, and then 1 plus A is 800 again, multiplied by the beta. Beta for the 1000 voltage per voltage we found out to be 0.099. And once we plug in all in and calculate this one, we are going to get the closed loop gain to be 9.9751 voltage per voltage. Now the things we are interested in is the percentage change, not the closed loop gain. So we have to calculate the percentage change. So in order to calculate the percentage change, what we do is let's put percentage change right here. Percentage change is nothing but delta AF over AF times 100. Delta AF is the value we have right here, that is 9.975. 9.9751 minus the closed loop gain that is provided to us, that is right here in the part B. You see that the closed loop gain provided is 10 voltage per voltage. So that's the one we put right here. That's the change. 10 in the denominator, we put 10 and multiply by 100, and you will end up getting negative 0.25% for this. Okay, similarly we do for the second one and third one. We had to follow exact same pattern. So again, let's do the part 2. In the second part, we have A to be 200 voltage per voltage. Now we have to see after 20% decrease. So the A new is going to be Again, same equation, a minus a times 20 over 100, and in this case, instead of a, we plug this value 200. So 200 minus 200 times 20 divided by 100. So this is going to be 2 times 20, 40. 200 minus 40, that's going to be 160. We're going to have 160 right here. And then now we find out the closed loop gain. AF is equal to A over 1 plus A times beta. And A is 160. So we put 160 right here. 1 plus 160. And for the 200, when A is equal to 200, we found out the beta values to be 0.095. So we plug that one right here. We did it in the part B of this question. 0.095. And calculate this one. You're going to end up getting the closed loop gain value to be 9.876 voltage per voltage. Now we have to find out the percentage change in AF. Percentage change in AF. That's gonna be delta F over AF times 100. F over AF times 100. Delta F is nothing but the value we found out here, that is 9.876 minus the value provided to us, that is 10. Okay, put that one here, divided by 10, multiply by 100, and you will end up getting the answer to be negative 1.24%. Okay, so this is the percentage change in AF for the part 2. Now let's look at the part 3. Part 3, we have A is equal to 15 voltage per voltage. So we have to first find out the gain after the 20% in decrease. So A new is going to be, again, same equation, A minus A times 20 over 100, and in this time we have A to be 15. So we plug that one right here, 15 minus 15 times 20 over 100, and here we are going to have 105 here, and then this is 105, then this is going to be 3, 15 minus 3, that is 12, and if this is 12, then AF is going to be A over 1 plus A times beta, which is 12 over equal sign 1 plus 12 times the beta we calculated for this one is 0.033. Okay, and we find out this closed loop gain to be 8.574 voltage per voltage. And now we have to find out the percentage change in AF. Which is delta AF over AF times 100, and let's put that one right here. So delta AF is nothing but this value, 8.574 multiplied by, actually minus by 10 divided by 10 times 100, and if you calculate this one, we are going to end up getting negative 14.26%, and that's the percentage change in AF. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.